What would you think if in the next 20 years we're gonna lose 25% of our whole marine life? For sure, I wouldn't want that. Good morning, my name is Damaris Jurado. I'm a civil engineering student of Universidad San Francisco de Quito. I come from Ecuador, a small yet beautiful country located in South America, well known for the Galápagos Islands. Today, I came to talk about a major concern that not only affects Ecuadorians but also people all around the world: the loss of coral reefs. Coral reefs are called the rainforest of the ocean because of its diversity in flora and fauna. They are communities of organisms where the main structural element are corals. Coral reefs are so important. Why? Well, because if they cover 1% of the seabed, they shelter 25% of the marine life. Only in one coral reef, they have more species than bigger areas of the ocean. Sadly, the increase of temperature has led severe coral bleaching. And what is coral bleaching? Well, it's when they lose these tiny algae that give them food and color. Since pre-industrial time, the Earth has warmed 1.2 degrees Celsius, and this has caused the loss of 40% of our coral reefs. If the Earth warms to 2 degrees, only 1% of the coral reefs will survive. They are not just important because of their marine life, but also they have a huge economic value. Only in the USA, they generate $3.4 billion per year through fishing and tourism. But not all is lost. Some initiatives have been created to restore and also regenerate these ecosystems. One of those are artificial coral reefs. What is artificial coral reefs? Well, they are structures created to transplant endangered corals to new areas, create a new habitat, and protect them from illegal fishing. Some examples of this are in the Gulf of Mexico, they sunk a ship, and they use this to create a new habitat for them. Also, in Hong Kong, they use 3D printing to create these artificial coral reefs. And now it's our turn to save the corals in the Galapagos using artificial concrete structure and for the artificial coral reef. And that's how our research approach was born. We didn't want to put something unnatural on the seabed, so a concrete structure was the best option. And we didn't want to have only a concrete structure, but also enhance the conditions for the proliferation of the life of the corals and marine life. So we wanted to add key components that will help them to grow. This research proposes the creation and design of an artificial coral reef made of concrete enhanced with calcium carbonate and tricalcium phosphate. The objectives of this research is, first, to design and evaluate a concrete mix using calcium carbonate and tricalcium phosphate. Also, to confirm the presence of these compounds using thermogravimetric analysis and also electron microscopy. And to test the compressive strength of these mixes with a weighted replacement of cement for these compounds. And finally, to design and build this structure and being implemented on Isabela Island in Galapagos Islands. The materials used are pozzolanic cement, calcium carbonate, and tricalcium phosphate. Okay, why calcium carbonate? Well, they are the main components of the coral skeleton. And tricalcium phosphate, they are the main components of hydroxyapatite. But what is hydroxyapatite? Don't forget about that word. I'm going to talk about this later. But this helps the growth and regeneration of the corals. For the methodology, we created first a control series with a water cement ratio of 0.42. Also, we had aggregated by volume of 65%. For the second series, we created a new sample with a partial weight replacement of cement for calcium carbonate. The second one, it's the same but a partial replacement for tricalcium phosphate in different percentages by weight, 5, 10, 20, and 40. And the fourth series is the mix of both compounds, calcium carbonate and tricalcium phosphate, with the concrete. First, the results of the compressive strength. We can see here the samples after 90 days of curing. We did the samples for 7, 14, 28, and 90, but since our research approach is long-term, we wanted to show these results. And here we can see that the compressive strength didn't decrease with the addition of these compounds. Moreover, it increased with the addition of calcium carbonate, which is a little bit logical, and tricalcium phosphate, compared to the control one. And the sample that had the biggest, the highest compressive strength is the one with 20% replacement by weight of calcium carbonate and tricalcium phosphate. In terms of workability, the sample with tricalcium phosphate had a lower workability than the one with calcium carbonate. We did air contact test and also a slump test for this. Okay, so in the methodology, we also wanted to analyze the content of these mixes, and we used the thermogravimetric analysis and in 3 different samples. The first one is the cement paste, that is the control sample. Then the second one with 40% replacement of calcium carbonate, and the third one with tricalcium phosphate. We did confirm that they had higher levels of this because what is really important in this research is that we want to have it in the structure. These 2 compounds is like having nutrients as substrates for the corals and for their marine life. It's adding the food that they need. So we will fasten the growth, we will help the regeneration, and will help the restoration of these ecosystems. In the scanning electron microscope imaging, in the control sample, we can observe what we already know about the cement paste matrix. So we can see the cement paste, we can see non-hydrated particles, the CH and CSH. And this one is with the one of 40% of calcium carbonate, and what we observe is a little bit more densified. But what is really interesting for us is this one that has tricalcium phosphate. And why is it so important? Well, we can see these little round shapes. And did you remember about that word that I told you? Well, we believe that is hydroxyapatite. This is an image of hydroxyapatite, and that's the one of the cement paste that we took. But what is hydroxyapatite? Well, we have it in our teeth, we have it in our bones. They are used in surgeries because its biocompatibility helps the regeneration of a calcium tissue. So if we have this in our structure, it will help the addition of the coral to the structure. Also, it would regenerate resistance to the acidification of the ocean. What does it mean? If the main event that caused the extinction of these ecosystems are bleaching. If we generate this resistance, we are going to keep our ecosystem of coral reefs in the whole world. After all of this, we decided to use the mix with 20% replacement of tricalcium phosphate and 20% replacement of calcium carbonate to create our artificial coral reef. For the design, we did a lot of research. We looked for a lot of shapes of artificial coral reefs, and also we wanted to see the condition that it needed to be applied and implemented on Isabela Island. We decided to have this hollow cube shape with a lot of holes because we needed a water circulation. Here we can see the front view and the top view of the design. Okay. For the structure, we use FRP reinforcement since it's going to be in the ocean and it has to be resistant to corrosion. And we want to have this for a long term. Also, we needed to have legs to anchor to the seabed, and we didn't want to have this structure sink on the seabed. So we designed a new shape of the legs. And what is really interesting is that for the formwork, we used Coca-Cola bottles since it had the shape that we needed, and also is economically viable. So if we want to be manufacturing and implementing in a bigger scale, this will be really useful. Well, here you can see also that for the hole we use pipes, PVC pipes. This is the finished structure, and it's pretty big. This is going to be implemented on Isabela Island on the Galapagos, next summer. This was delayed because, well, in Ecuador, we had the biggest drought in 70 years, and the energy matrix in Ecuador is based on hydroelectrics. So it was a little delayed, but if you invite me the next one, I will tell you the results, because this is a multidisciplinary research, and we have biology people that it's going to help with the data of the corals. Okay, in conclusion, the compressive strength was not affected by the addition of calcium carbonate and tricalcium phosphate. Moreover, it increased. The tricalcium phosphate did reduce the workability of concrete. The presence of these two compounds were confirmed with the use of TGA and SEM. And the last one is that we successfully designed and built the artificial coral reef.